Deb here. So we're going to do a titration lab, and the titration lab actually has 3 parts. Usually we do this in 2 lab periods, but instead we're going to try and do this in the lecture and lab periods. We're going to do the whole lab in one evening. So you have to make sure you're really organized and you have your introduction written, and there's a calculation you also have to have ready to go. And then you're going to have 3 parts that you're going to do in this lab, and after each part you'll have a calculation to do, a series of calculations, and you need to bring it to your instructor. So basically your instructor would like to see your lab 4 times. First, before the lab starts, you should have your introduction. After part 1, when you get the molarity of sodium hydroxide. After part 2, when you have the percent by mass and the molarity of vinegar. And part 3, when you figure out the molar mass of your unknown acid and what is your unknown acid. So you're really going to be coming to your instructor 4 times for signatures through this lab. So I'd like to help you write the introduction. You should have the title and the objective written before you come, and the introduction, and there's 1 calculation I'm also going to show you that you have before you come. So you should probably say, what is a titration? And that definition is in your lab manual. It's in here. And that if you titrate with an indicator, in this case we're going to use phenolphthalein. Phenolphthalein is the indicator that can tell you when you come to an equivalence point. And in particular, phenolphthalein changes around pH 7, which is when your moles of hydrogen ion will equal your moles of hydroxide ion. It would also be nice if you put a graph in your introduction, and I have posted a video with that graph. You should talk about the fact that sodium hydroxide is hygroscopic and it absorbs water. It also reacts with CO2 in the air, so you really can't measure the mass of sodium hydroxide, and therefore you can't really make molarity sodium hydroxide solution that you know the molarity, so you have to standardize it, which means you have to titrate it with something else, and a good choice is going to be our KHP. And so in the introduction, then you should write the reaction between sodium hydroxide and KHP. You should also talk about what is vinegar. Vinegar is basically dilute acetic acid. And you should say, have the reaction between sodium hydroxide and acetic acid. And then for the 3rd part, what is the difference between a monoprotic and a diprotic acid? Monoprotic releases 1 hydrogen, a diprotic releases 2 ions, and have the reaction between sodium hydroxide and a monoprotic and sodium hydroxide and a diprotic. So those are some hints of what should be in the introduction, and then I'm going to show you the calculation that should be also in the introduction. So on the 3rd part of this lab is the titration using your sodium hydroxide that you standardize in part 1, and you're going to use that sodium hydroxide to titrate an unknown acid. The acid will be given to you in a solid form that you dissolve in water, and then you have to figure out what's the molar mass of my acid, and then by looking at a chart, 1, 2, 3, 4, 5 choices with molar masses, you can see which molar mass does yours is yours the closest to, and then you can say, well, that's probably the acid I have. Now, one thing is you don't really know what acid you have, and you're going to titrate it with sodium hydroxide. You do not want to use more than 25 milliliters of sodium hydroxide, because your burette holds 25 milliliters of sodium hydroxide. And if you go past 25, you have to refill it. And that's a pain. And then you have to add the 2 volumes together. So you're introducing more and more error when you do all that. So I'm going to show you a calculation that you should have done before you come to class. So you know in part 3 approximately how much unknown acid should you use. This is approximate. You don't have to get exact. So we want to use at least 0.1 grams. Because we want at least 3 significant digits. And we don't want to use more than 25 milliliters of sodium hydroxide. And of all the unknown acids, the one that has the smallest molar mass is the malonic acid. And so, assuming, let's say that's the one you got, that's the one that you would use the most. So we're going to use malonic acid to figure out how much of our acid should we use. If you get a different unknown, then you're in the safe zone, okay? Because you know that you have the right amount. So right here is moles to liter, which is molarity of sodium hydroxide. Now, your actual calculation, you would say, okay, I'm going to put in exactly what the molarity is. But it's going to be about 0.2. So this is all rough, because this isn't telling you exactly how much acid you should use. It's just approximately. And this is malonic acid is monoprotic, so it's a 1-to-1 ratio in the reaction of your acid to your base. And right here, you should put in the molar mass. It's given right here, 104.062 grams. So if you do this calculation, it'll tell you approximately how much acid to use. And this is on part 3. Now, I wouldn't go over this, because this calculation is for malonic acid in 25 milliliters. So if you say you did get malonic acid and you use this exact number, you're really pushing the limit. I would probably go a little bit less than this, just in case you got malonic acid. Now, if you have something that has a larger molar mass than this, then you're safe with this. Thank you.